All right, guys, welcome to your first video lesson. Tomorrow there will be a mini quiz over just some basic stuff that I'm going to talk to you guys about in this lesson. So just stay awake. I'll be done 9 or 10 minutes. We'll be done with this, okay? So the periodic table is a huge part of chemistry, and there is so much information embedded in this table. We're just going to go over the basics. The first thing that I want to talk about are the 3 different types of elements. There are metals, and then there are metalloids, and I'm going to circle these because this is the periodic table that is on the back wall in my classroom, and it's actually already labeled. Now, I don't have the metals labeled on the table in the classroom because it's kind of process of elimination. If these are my metalloids, okay, these that are shaded in green, a light green color, the ones I'm circling, these 6, and then the ones that are shaded in red, in this light kind of red, are my nonmetals. Well, then that means that everything that's not shaded are my metals. Okay, so right here, so in saying that, you can see that most of our periodic table is made up of metals. Now, don't get it in your head that metals all look like copper and nickel and coins. A lot of people think, when they think of metals, they think of just like shiny things or very sturdy, solid things, because some metals are actually very brittle, okay? They're kind of powdery, very brittle, all right, and not nearly as sturdy and durable as some metals can be, all right? So to be a metal, it just simply means that you are a good conductor of heat and electricity, and that you have some degree of luster, but then you may not have any at all right? And that your overall structure and appearance may not actually look like a coin, or what we consider coins and metals and different things that we think of in different goods and products that we use. All right, but most of the table are metals. They're good conductors of heat and electricity. All right, and you can see that that makes up most of the periodic table. Now, there are 6 metalloids. They are right here. They are what separates the metals from the nonmetals. Metalloids are also known as semi-metals. And the thing is, these elements, they just can't make up their mind whether they want to be a metal or a nonmetal, so they're a metalloid. Okay, they've got properties that are similar to metals, but also similar to nonmetals. And it's these 6 right here that separate the metals from the nonmetals. All right, now that leaves us with the nonmetals. Now, nonmetals, a big thing that is assumed about nonmetals is that these are all gases. Actually, they're not. There's several of them that are gases, but the carbon, for example, phosphorus, sulfur, selenium, iodine, they are actually solid non-metals. So just because you're a non-metal doesn't make you a gas. It just means you're not metallic. It means you're a poor conductor of heat and electricity, okay? So those that I've circled are our non-metals. So those are your 3 types of elements on the periodic table. So you got 3 different types. All right, so let's talk about the overall structure of the table. There are groups on the table, and there are actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 up and down groups on the periodic table. So these are our groups, columns, whatever you want to refer to them, but there are 18 of them, all right? Now, there are some important groups on the periodic table that I will point out in just a second, but I want to talk about the opposing organization of the table, which is in rows or periods. So, a period... A period is what goes back and forth. So this is a period. A period is what goes left and right horizontal through the table. There are 1, 2, 3, 4, 5, 6, 7 periods. All right. All right. Now, so going back to the names of our groups, there is, or not just the names, because we're not going to learn all the names of the different groups on the periodic table. We're going to talk about some important groups, all right? So I'm going to first start by talking about this group right here. This group right here is known as the noble gases. The noble gases are important because they are the only group of elements that are stable alone. So helium atoms, neon atoms, argon atoms, krypton atoms, xenon and radon atoms do not want to chemically bond and chemically react with other elements because they don't need to. They are happy, stable elements. So they are very unreactive. Now, we can say that about noble gases because they have what is known as a full valence shell. They don't need any more electrons. They just have this magic number of 8. And we'll talk more about that later. But just for now, know that the noble gases are independent elements that exist on their own simply because they do not need to react or chemically combine and bond with other elements. Now, this group right next door, excluding number 85, these are what are known as the halogens. Now, the halogens, unlike the noble gases, are extremely reactive. Now, the reason why they're so extremely reactive is because they are 1 electron shy of becoming chemically stable. So they have a very strong nucleus, all right? And so they have very strong nuclei, and they're very eager to become chemically stable. They just react very readily. Now, these are also, that means they are very good oxidizers, meaning that they can strip electrons away from other atoms and actually lead to ignition or combustion, and that is an increased flammability. So these are your halogens right here in group 17, very reactive nonmetals, all right? Now, other reactive groups would be these two over here, all right? These two groups of metals. Now, once again, don't forget, most of the table is metals, but these right here can be reactive, some of them, but as a whole, these two groups can be very reactive. They are known as the alkali. So this is the alkali metals, group 1 are our alkali metals, and then group 2 are our alkaline earth metals. Now, so their names are somewhat similar, but they are different. All right, now see how hydrogen is over here with the alkali metals? It's like an honorary member that is structurally in group 1, but it's really not an alkali metal because, first of all, it's a non-metal. But we'll talk about later on why hydrogen is actually over here with the alkali metals. But for now, just know that these are two of our very reactive groups of metals. All right, alkaline earth metals and alkali metals are very reactive metals. Our halogens is our extremely reactive group of non-metals. All right, and then of course our noble gases are not reactive at all. Now, one more group that I want to talk about, and just this has to do with the structure of the table as well, are the transition metals and the intertransition metals. So right here, this is what is known as the transition metals. This is known as just kind of one big group. Granted, it's 3 through 12. It's 3, 4, 5, 6. That's actually 10 different groups, but they are known as the transition metals, groups 3 through 12, all right? Now, down here at the bottom, these are the intertransition metals, and they are also a part of period 6 and 7. So a lot of people are like, okay, here's period 1, 2, 3, 4, 5, 6, 7. They are actually an extension, and I'm going to get rid of some of this. But the intertransition metals, which is also known as the Lanthanide and Actinide series, they are actually apart. This is like the extended row of, or extension of period 6 and period 7. So actually, if the periodic table was going to be to scale, if the periodic table was actually going to have the structure that it was intended to have, these right here would go back here. This is number 57, because you can see here's 56, here's number 57, and then right here, actinium would be right here. So actually, the periodic table, the last two rows or periods would actually extend out much further. But to condense the table, period 6 and 7 have these two extensions known as the intertransition metals, or also known as the lanthanide and actinide series. Now, the reason why they're called the lanthanide and actinide series is because right here, this is lanthanum, so this is your lactinide series. Oh, I said that wrong. Oops. That's your lanthanide series. And then you've got your actinide series that starts with actinium. So actinide series, lanthanide and actinide series. Now, you might be wondering about the colors on the elements. The colors on the elements is due to, so you might see that some of these are transparent. These are actually synthetic elements, meaning that they're man-made. So every single one of them you see that's clear is actually, or transparent, is a man-made element and not naturally occurring in nature. Those that are in blue, like right here, these are bromine and mercury, are actually liquids at room temperature. And then those that are in black, which is several of the elements, they are solids at room temperature, so all of them in black font. Now, the ones that are in red font, like all of these, the lettering is actually red, hydrogen, those are gases at room temperature. All right, the last thing I want to mention is the numbers associated with each element on the periodic table. So I'm going to take, for instance, iron. So see how iron has number 26? That number 26 is known as the atomic number. The atomic number, or the smaller number, as students like to call it, the atomic number is the proton count. So every iron atom that exists out there has 26 protons inside of its nucleus. No other element has that. So every cobalt has 27. So the atomic number is also known as the proton count, okay? And it is what we would call the smaller number of the two numbers around the elements symbol on the periodic table. So some students want to say, what's the one on top or the one on bottom? Just remember that it's the smaller one. Now, the one that is on the bottom, this right here, is a decimal because it's just an average. Like, that's like on average, that's how much an iron atom weighs, 55.845. But if we round this, that rounds to 56. So on average, the atomic mass, so this is not called the atomic number, it's called the atomic mass number, or just the atomic mass, is 56 for iron, okay? So on average. Now, we'll talk more about how that average comes about in another lesson, but just know that the atomic mass is your larger number. The atomic number is the smaller number that belongs with each element. So the 26 with iron is its atomic number, all right, which is also its proton count. All right, so that is basics of the periodic table and a lot of it's review from physical science information, but it is what you need to know as we journey into the next couple of days regarding the periodic table.